Hi, let's talk about content-based recommendation systems. We talked before about collaborative filtering, and today we're going to talk about content-based recommendation systems. Let me tell you what I think are the main differences between the two. So the way to think about it is the following. In collaborative filtering, you were using the history of users liking items. So basically, you are using the behavior of a particular user, and in aggregate, what you are trying to figure out is users that have different similar taste. So or users that are close to each other in taste, right? And then by looking at similar users, then you can make recommendations to me, for example, based on users that are similar to me. So again, in collaborative filtering, we are using behavior of users. So we just need to know, for me, all the movies I have watched in my life, for example, or all the movies I have watched in the last 2 years, and also about the same data about a bunch of users, right? So, and that is enough to make recommendations. In the content-based systems, what we're doing is that now you know a few things about me, some things I like, but we're using the content of those items to make recommendations. So, for example, you can have, like, say, books or movies, and we will compute attributes based on the content of these movies or books, and we're going to use those to make recommendation. What can we do with these attributes? For example, I can compute also a profile of a user by looking at the items this user like and looking at the content of these items. You can also have a profile of a user, and then you can try to match user profiles against content or items profile to make recommendations. Okay, so let's talk about this a little bit more. So this is another diagram here in which in one part I have a collaborative filtering. So again, I have the history of two users. Based on that history, I can compute similarity between users. And then, for example, there is this blue person here. We can find the most similar user, which is the person in purple, and we can make recommendations to the blue person based on things that the purple person liked. Okay, so we are using the behavior of these two users, which is a lot of books they read or movies they watched, to then compute the similarity and then make recommendations. That is collaborative filtering. In content-based filtering, what we're doing is that we're also looking at a user and maybe some of the books he have read, but then we are actually looking at the content of these books to compute similarities between items. And based on this content similarity is that we make recommendations. So let's look at another example to make it more clear, okay? So suppose you run a website that recommends blog posts to users. And suppose you don't collect user IDs or cookies or anything, right? So you don't really have a history for a particular user. What you have is that blogs have words. So you can compute similarities between different blog posts. And for example, I am going to that website. I've never been there before, so you don't have any information about me, but I'm reading a particular blog post. So you can recommend other blog posts to me based on the content of that particular blog post that I'm reading. And that is content-based recommendations. Okay, I hope it's more clear right now. So what are the ingredients of content-based recommendation? Well, we need an item representation. So we need a representation of each item based on the content of that item. We also may want a user representation, but the user representation is mostly computed from the content of the items that that user liked. Okay. Then we may need some similarity metrics. So maybe we want to know what are the items that are similar based on some kind of metric. It may be that we were going to use some machine learning model. And finally, we need ratings. So we need to know something, about what do you like, maybe. Okay. So let's look at an example. Music is one of these places in which people use content-based recommendations because there is so much content to analyze. So we have users, and if you have been in Pandora or some other music app for a while, they have some idea of what you like. So what type of music preference you have. Um, Maybe they know something about your demographics as well. Maybe in a particular period of time they can tell what is the intent, what type of music you want to listen to right now. And maybe actually they also may kind of detect the context that you are in. For example, you may be trying to do some yoga, so and that will require a particular type of music. Or you may be doing some Zumba class, which would require a completely different type of music. And maybe they may be able to use that. So on the other side, you have the items, and you know a lot about the items because you can compute things like melody, harmony, structure of the music. So people tag music a lot, so you can use the tags that are associated with a particular song. You can think about the purpose of the song. Maybe the song is political or spiritual. Maybe the author himself has some kind of political intent, for example. You can also use a lot of other things about the music itself. If there is a music with video, you can use things about the video, features about the video, and so on. So these are some of the information that can be used in a content-based music recommendation system. So let's think about how are we going to compute the profile of a song, of an item in this music recommendation system. So the first thing that we can do is to do some kind of audio content analysis. So we can compute things like the beat, the timbre, the tonal features. We can use deep learning to figure out the genre, like say bachata, bolero, forró, merengue, blues of the music itself. You can also use deep learning to use some kind of categories such as not danceable or gender male or not happy mood. And this could be trained based on user tagging or expert taggings, right? And some libraries would do this already for you. So we talk about audio content, but can also analyze text content. And the text could be the lyrics itself, or it could be the text generated by users about this particular song. So let's now pivot and talk about, for example, how do we compute the profile of a movie for a movie recommendation system. So a movie has a lot of different things we can talk about. We can talk about the actors in the movie. We can talk about the director, the year the movie was made, the genre of the movie. Uh, what about other features? Can we make features from reviews? How can we get a user profile? Can we get features from the video itself of the movie? Well, all of that can be done, right? So here are some other ideas. So you can also think about the location of the movie or the location in which the movie is successful. You can think about image features or audio features, and things like that. So there are many things. Anything that you can compute about an item, in this case a movie, can be thought about a content feature. So, and how can we use these content features to then compute user features? So the way to think about a user feature could be a summary of the profile of the features of the items this user like. So if I have watched like 10 movies in the last year, you can look at all of the features of these 10 movies and make an aggregate of what is my user profile. Okay. We can add all things to the user profile. For example, demographics, declared interest, some kind of location, other features like the last time this person visited the website, the frequency of visits, search history. So there are other things you can add also to the user profile. What about features from documents? So, well, there are many ways in which we can look at features from document. One kind of basic way to do it is to do some kind of TF-IDF. For example, you remove stop words, you compute the TF-IDF scores of all the words, and you keep, for example, the top, 10,000 of them. And that would be the representation of your document. Another possibility is that you do some kind of word embeddings on all the words and keep some kind of summary of that, or you do some kind of sentence embedding or paragraph embeddings. So there are many ways in which you can compute features from documents. There is another way of computing features for document that people use is called topic modeling. So you use some kind of unsupervised or supervised method to compute some topic models, and then you can represent your document as a vector P1, P2, Pk, in which Pi is the probability that a document belongs to topic I. Yeah, and that's another way that people represent documents. So now that we have talked about how do we represent a profile of an item or profile also of a user, let's talk about how do we go about understanding items that are similar to each other. And one way to do that is to think about similarity metrics. So you can measure how similar are two items or users, and which similarities you use depends on the application that you are using. That are using the type of data you have basically, and the type of similarity that makes more sense for your data. Then, based on those similarities, you can use something like K-nearest neighbors to understand recommendations. So, if I have a particular book, what you can do is to look at the similarities within this book and all the other books and pick the top K books. And those would be the ones that maybe you want to recommend. So let's talk about some similarities, okay? So the first one is the Jaccard similarities. So given two sets A and B, you can compute basically what you do is that you take the intersection between A and B and you divide by the union of A and B. One example on how to use this is that suppose that, so I watched 10 movies in the last year, let's say, right? And you look at somebody else and look at what movies this person have watched in the last year, and then you take the union of these two and divide by the intersection of these two and divide by the union, and there will be the similarity between me and that person, right? So that's kind of one way to think about how to compute similarities between set of movies, for example. Same with set of books or things like that, right? So another similarity that people use is cosine similarity, and it's basically you have two vectors. Mostly it's used for vectors that are in which every element is bigger or equal than 0. And then you consider the cosine of the angle between these two vectors. So this is often used to compute similarity between documents. And yeah, it's between documents, and is used mostly when all the elements between x and y, in this case these two vectors, are bigger or equal than 0. So you can also use Pearson coefficient, which is computing the linear correlation between two variables, and that's another metric people use. So here I have an exercise for you guys. I want you to consider the following utility metrics, in which we have 3 users, capital A, capital B, and capital C. And we have items lowercase a, b, c, d, e, f, g, h. And I would like you to stop the video and to compute the different similarities between these users. So I'm gonna let you stop the video, but I'm gonna keep going. So how we recommend items to users? So, one way that you can do this is that, suppose that you have profile vectors for users and items, you can find your favorite similarity metric, and then you can compute similarity between users and items. You can also compute similarities between just items or between just users based on content as well. And then we recommend to a user items that have high similarity, or you recommend to a user items that have high similarities to other items that user have seen in the past. Okay, using k nearest neighbors. K nearest neighbors it doesn't scale very well, because you have to compute distances between all of the items involved, or items and users. So in large scale is not that feasible. But there are methods in which you can do this approximately. One of them is called locality sensitive hashing techniques. But I just wanted to mention that there are you can find approximate k nearest neighbors that work very well. Another possibility is that you train a model. Okay, so suppose that you have, for example, ratings. You have users rating different movies, and you have given an observation would be an item, a user, and a rating. And you have a lot of features about the item, lots of features about the user, and then you have a rating. So one thing you can do is to train a machine learning model, for example, a random forest or logistic regression, or whatever regression or whatever you want, to predict that rating. If you don't run rating, but you have implicit ratings, then you would do something similar to what we talked about in a previous video. So you would have to have some kind of target, 0, 1, or something like that. And then again, you have a user, an item, and a rating. Could be 0, could be 1. You have a user profile, you have an item profile, and you can use all of that to predict the rating. Okay. And this is mostly in which a lot of the current recommendation systems would the way they will work. So what are the advantages or disadvantages of content-based recommendation systems? One thing is that you don't need data on other users. So more clearly, you don't have a cold start problem for an item. What is a cold start problem? The cold start problem is a problem when you have, for example, a new item or a new user that you don't have data for, and you don't know how to do recommendations. So suppose that you have a new item. Well, that item has a content-based representation, so you can use that representation to recommend users to that item. You can also provide explanations based on content. So basically, since you are since you have this content, and maybe you have a model, you can maybe tell people why you are doing this particular recommendation based on the content of your item. So the disadvantage of content-based recommendation system is that you need a domain knowledge. You need people tagging and doing the content analysis of your items. So some of this could be done automatically, but some of these may be done for basically people maybe doing that, and some items are less amenable to feature extraction. So like movies, for example. Yeah. So at the end of the day, what we always have is that no one recommendation system is either content based or collaborative filtering. So most people try to do some hybrid system in which you do a combination of content based and collaborative filtering. So let's talk about for a second about the cold start problem. So every recommendation system is going to have this issue that you're going to have a new user on a new movie, right? So, and what if you don't know anything about this kind of, for example, this user, right? Or this item, nobody has rated this item yet, okay? So, so yeah, so basically that is the issue. So you don't have any explicit ratings, or you have very few ratings about a user or an item. So if you have a new item, you may use the content based kind of recommendation system to do recommendations on that item. So that we talk about that already. For new users, the cold start problem is a little bit more difficult, but you can recommend popular items, or you can ask users to give you some interest. So basically, for example, when you go to Quora and you're a new user, Quora asks you, "Hey, could you tell me what are your interests so that I can recommend, you know, stories and questions to you." You may be able to use some kind of like social network data. If you are asked to provide your Facebook login or something, they may be able to use some data about your friends and what your friends like to basically maybe get some features on you as well. And this is the end for now. See you later.